Maya, a young epidemiologist from a small town in India, grew up witnessing the devastating impact of dengue fever on her community. Each monsoon season brought a surge in cases, overwhelming local healthcare resources and causing widespread suffering. Motivated by these experiences, Maya pursued a career in data science, believing that analyzing disease data could provide crucial insights to better manage and prevent outbreaks. In 2023, following a particularly severe dengue outbreak, Maya decided to apply her data science skills to help her community. She gathered historical dengue case data and wrote a program to analyze and visualize the trends over time. By converting the scattered data into a clear monthly timeline, Maya created a plot that highlighted seasonal peaks and helped local health officials understand and anticipate future outbreaks. She then contacted the nearby public health office and sent a letter detailing the situation in her city. In her letter, Maya requested actions to control the outbreaks, emphasizing the clear seasonal patterns revealed by her analysis. Her work not only provided actionable insights, but also demonstrated the powerful role of data in public health planning and intervention. In the next section, I have explained what she actually did and how she did it. Hello, and welcome to our tutorial on creating a line chart to visualize the trend of dengue cases over time using Python. Today, we'll be working with pandas and matplotlib to achieve this. Let's dive into the code. In the first step, we import the necessary libraries. We use pandas for data manipulation and matplotlib for plotting our data. If you don't have these libraries installed, you can easily add them using pip install pandas matplotlib. Next, we load our data from a CSV file named synthetic dengue cases.csv. This file should contain at least 2 columns, one for dates and one for the number of dengue cases. We use pd.read_csv to read the data into a pandas data frame, which makes it easy to manipulate and analyze. We need to ensure our date column is in a datetime format so that pandas can recognize it as dates rather than plain text. The pd.toDateTime function converts the date column into datetime objects, which is crucial for time series analysis. With the dates properly formatted, we set the date column as the index of our data frame using setIndex. This allows us to directly work with dates for resampling and plotting. The inPlace equals to true argument modifies the data frame in place. Now, we resample our data to aggregate it by month. This helps in smoothing out daily fluctuations and gives a clearer picture of trends over time. We use resample m.sum to sum up the cases for each month. The M stands for monthly. Let's move on to plotting the data. First, we set up our figure size using plt.figure fig size equals 10:6 to make sure our chart is clear and readable. Then we plot our resampled data using plt.plot. We specify the x-axis as the date index and the y-axis as the number of cases. The marker equals O adds dots at each data point, and line style equals dash connects these points with a line. We chose blue, color equals B, for our line color. Next, we add a title and labels to our chart. .plt.title sets the main title of the chart. plt.xLabel and plt.ylabel label the x-axis and y-axis, respectively, providing context for what our axes represent. To enhance readability, we add a grid with plt.grid true, which helps in tracing values more easily. We rotate the x-axis labels with plt.xticks, rotation.45, so that the dates are easier to read. Finally, plt.tightLayout adjusts the spacing around the plot to make sure everything fits nicely within the figure. And lastly, we display the chart with plt.show. This renders our line chart on the screen, showing the trend of dengue cases over time. That's it. You now have a line chart displaying the trend of dengue cases over time. This visualization can help in understanding how the outbreak evolves across different periods. Thank you for following along, and happy coding.